Hello, this is lab 3 about frictions. You start from the file, you download online, and then we're going to use two simulations from FiatNet. First, you're going to use this one, and you will start from here. And this tells you what is see you have the two surfaces and two layer. You can just move this up to each other and see. And also, like you said, we have the simulations and to observe what's happening when two surfaces rubbing into each other and what surface causes. And there is a thermometer there. You can see that when the two surfaces rubbing between each other, and then the atoms and molecules move faster, and things get hotter, and temperature rises. And this is just a simple play and to understand the origin of friction force. Then you need to answer these questions and friction. What is the cause of a friction force between surfaces because of the roughness of surface, and true or false? I don't want to give you the answer. As you learn later in the class, temperature of an object is related to how fast an atom or molecules move inside. The faster the particle moves, the what? Okay, fill in the blank. And also here's the true or false questions. I don't want to give you an answer, but I'll let you think about it first. And then the next part is about the simulation. You start from this application and let you look at, if you click here and choose this, and we have a Fiat simulation, we can have different kind of object move on different surfaces. So, and apply different kind of friction coefficients, and then to see how it works. So then the first one is, so you play with it. So basically you click force graph, and then you can choose on the right file cabinet, and this is 50 kilograms, and then file cabinet, and on top of it choose wood, and then it's like cabinet on wood. And what you can do is you actively apply a force, say apply a force, and then now on the right you can apply, say, 100 newtons, and then you can play. And then of course if it moves, and here it plot acceleration, you click velocity to display and also position to display. All right, and then display the force and also display the free body diagram. What are the forces? See, normal force, gravity force, applied force, and the friction force. In this case, you see these two forces cancelled up and down, and this is from the right and left. The applied force got cancelled by the friction force, so the object just stays in this case. And then so that's when you do this, you do a simulation, and then of course we'll plot the time on this. But in this case, nothing interesting, because it goes applied force is very small, 100, and then acceleration on the right, it displays 0, and velocity, because there's no acceleration, velocity stays the same. The position you can adjust from starting position. The initial position is -2 meters, and it's -2 meters. As time goes on, now it's already 12 seconds, then 13 seconds, and then 14 seconds. Nothing happens. The cabinet just stay there. So then stop, and then you can clear, and you can play back, replay. You can, if you forgot some of the feature, you can play again, and then you can change to, say, 200 newtons applied force. In this case, and then the friction force is also 200. So in this case, but still nothing happens. See then you can see the force is stronger, 200, but then 200 friction force to cancel it, and then still not moving. And then, so then of course at the same time, you would put all this data in the lab report. Okay, so you put this inside 100 and some number, and then let me see, and also there's a sample file. Okay, and you start from this regular file. Okay, so the sample file, say for example I give 100, the net force is 0, but the friction force is also negative 100. The total is 0. And of course you put weight 50 times 9.8, the gravitational force, which is downward. And the normal force is the supporting force to the cabinet, which is pointing up. Acceleration, because of all the forces that canceled to 0, and of course the time to the wall. Visual simulation, if the object will start moving, and it will hit the wall at some time, and then time to hit the wall, because if you plot, you will see the velocity goes up, all of a sudden, boom, jump to 0. You will see how long time to hit the wall. And to give you the idea about how fast how things are going, and probably we don't, since a lot of velocity and everything is plotted there, I don't want you to plot, but I just want to see some features. You will see that the stronger the acceleration, the faster they hit the wall. So then you just put the time to the wall, and of course the friction coefficients and the kinetic are given. So static friction 0.5, which means at least half of whatever the normal force is. You're pressing from the down, say 10 newtons, and then there will be 5 newtons maximum, minimal, to get things to move. But once it's moved, and kinetic friction is much less than not much less, but usually less than the friction force, that's 0.2. These two numbers are given. Across the board, these are all stay the same. So now you choose to simulate this. And now if you put, say, 300, okay, and so now, so you play the back and clear, and I'm not really good at this yet, so you can always reset and restart, and remember you have to choose the file cabinet and choose, okay, 300. Use your physics knowledge, see if this number makes sense. 300 newtons, and simulations, and the total displayed here. And watch. Now you see the free body diagram. In this case, the applied force is a little bit bigger than the friction force now. So it's overcome the friction force. It's longer. Therefore, the cabinet will start moving. Okay, and once it starts moving, it has the kinetic friction. It's not exactly canceling. So go, and then boom, and see it's going. Boom, it hits the wall. See, if I ask you, the question is, how far, when it hits the wall, how long does it take? So it's like the velocity. If you look, you display this velocity, the velocity goes up, it's accelerating, and boom, goes down. It's like you say, so that's 3 seconds, 2.4 seconds. So you put here something like 4.2, 2.4, and 4.2 or 2.4. Let's see. So so the sample data. So I have 300. So it's 4.2, 2.4, not 4.2. Okay, and 4.2, 2.4, 2.4. So second to hit the wall, and what is the net force? So the net force, if you start, you can replay again. You can see net force. Though this is 98 friction force. So if you look at this friction force. So it's 98, So that's kinetic friction, and then this net force is 202 because you see it's 202. But just if you clear this everything and record again, and then 300. Or sometimes it just recorded the previous one. Then you have to bring the things back to -2. So you can always set to -2, or you can just type it in. So -2. So it's there. Now see the kinetic friction. If you go stop and in the middle, and you will see 395 is the resistance force, and then 202 is the net force. Okay, so it cancels. 202 is the net force, that weight is the same, and then so on. And so on. So of course this is the sample in yours. You can look at this file and realize this is the sample, and then yours, it will be blank. You should fill all the data out. And so actually between 200 and 300 there's a threshold. In other words, below 200 basically the object is not moving. So you would see no acceleration. That's irrelevant. Okay, time to the wall is irrelevant, and these are the same, but it's not moving. So once you be beyond 300, then you have kinetic friction. The object is moving. You will actually have all the data here. You have acceleration, which you read from this box, and you can, if it's out, you can just always reset and see if it makes sense. And then you have 400 and so on. Keep on simulate all the way to 800. In that case, all the kinetic friction will be -98. So I basically give out the answers. But then, important thing is you find out where is the threshold, which means between 200 and 300, there is a maximum value, or there's a value between 200 and 300, and where this object starts moving. So, in other words, if you look at the free body diagram, and then there is when these two are equal and on the verge are equal, when they equal, so that's a critical point. Once it's beyond that, and then it will start moving. It's around 240 something, 245, 246, 247. It's for you to find out, and so find out and then do a simulation in that column. You put in this one is a little bit. Yeah, that's a little bit challenge. So you need to do some trial and error to find out the maximum static friction. That's what I'm rating here, a threshold of the applied force. Be patient. Once the object starts moving, the friction force become smaller. That's called kinetic friction. And in this case, it's always 98. And of course, you answer this question. Once you have that, you will need to graph the friction versus applied force. I draw that picture in the class. It's a straight line, and but you know, more applied force, more friction, more applied, but that's only below the maximum friction. Once it beyond the maximum static friction, and then you will have a flat, basically plateau, and that's kinetic friction. Okay, like a kind of like a sawtooth, okay, and like that. But you draw exactly to the scale and mark where is this maximum static friction. Okay, and hope this is helpful. And also I want you to calculate when to find out, and also calculate with the maximum and kinetic friction or static friction. That is simply the normal force times the coefficients, and you compare, see if they are equal. And this is a simple and fun experiment. Okay, if you have questions, you can always get on the Zoom and talk to me, or we can answer further questions.